So this is the same exercise which is related to distance, time, and speed time graphs. Continuation of questions. Question 25 from page 30. A small metal ball is projected into air. So means we throw an object upward. When we throw an object upward, the initial velocity was 40 meter per second. Then when it goes up, it's because it will decelerate, it slow down, and eventually it will reach zero. So when it is at maximum height, this is the point where it is at maximum height. So when it reaches the maximum height, the speed will be zero. And then what will happen? It will come down. When it will come down, if we are talking about the velocity, so if it is going up, we have a positive velocity, then coming down will be a negative velocity. So when we represent the motion, we'll represent the motion in negative axis. So the first part of the question, use the graph, find the time at which it reaches a maximum height. So how we know at what point it reaches a maximum height? Maximum height means where this, because when object is projected upward, at maximum height, the speed will be zero. So at what point the speed is zero? At what time interval? So this is the point where the speed is zero, which is 4.1. So means it took 4.1 second to reach the maximum height. The deceleration of a ball, how to work out a deceleration? The same formula, it's a straight line. So starting speed is 40. The final speed at maximum height is 0 and the time is 4.1. So final is 0, initial is 40, divided by time interval is 4.1. So 40, we'll get as negative 9.8. Negative sign shows that it is decelerating. So it will be 9.8 meter per second square. Because they already mentioned it's a deceleration, so mentioning a negative sign is not important. Just the magnitude is important. Negative sign shows that it is decelerating on a negative acceleration, which also means deceleration. The maximum height of the ball reached by the ball. So maximum height reached by the ball is area under this graph, because at maximum height the speed will be zero. So we find area under this graph. So half base into height, which is 40. That is equals to 82 meter. That's a maximum height. Then speed time, two graphs are there, speed time graphs. So first one, because it's a straight line, speed is increasing, but the acceleration is constant. Here, acceleration constant, because it's a constant gradient. So acceleration is not changing and speed increase. What about the second graph? The acceleration is decreasing because the slope is decreasing. So acceleration decrease, but the speed is increasing because speed is on the y-axis. So the value on the y-axis is continuously increasing. That's why the both cases, the speed is increasing. Like here, the value of the speed is getting higher. Here also the value of speed is getting higher. But the slope, for the first one, the gradient or the slope is constant. And for second one, the gradient or the slope is decreasing. In question 27, acceleration of a falling object on Earth is 10. Calculate the time. So if you want to calculate a time, whenever object is falling, and they mention it reaches 32 meter per second. When it is initially, it will have a 0. And we need the time, so which is v minus u over t. Acceleration, we take 10. Otherwise, the more recent papers, you should take 9.8. But for this question, already they mentioned 10, so you will take as 10. Final speed is 32, initial is 0, and time we don't know. If we need the time, we cross multiply. So time is 32 minus 0 divided by 10. Or 32 minus 0 is 32 divided by 10, which is 3.2. And the unit will be second. So 3.2 seconds. On figure 1.1, draw a speed time graph for a falling stone. So when time is 3.2, 10 boxes equals to 1. So each is 0.1. So this would be 3.2. The speed was 32. So, and it is falling at a constant acceleration. So a straight line will be there. So when 32 and 3.2, then we'll draw a straight line. Because this falling object, as I mentioned, it's falling with a constant acceleration. So it will be a straight line. In question 28, a large plastic ball is dropped from a tall building. Figure 1.1 shows a speed time graph. As the air resistance is opposing the motion, acceleration decrease until it reaches a terminal speed. During the time during which the ball is traveling at a terminal velocity or constant velocity. So at this point, it starts its terminal velocity and it continues till this point. So it starts from 4.1 and ending at 6. So what is the duration from 4.1 to 6? That's equal to 1.9 seconds. So for 1.9 seconds, it was moving at a terminal speed or a constant speed. Time during which the ball was accelerating. So till this point, because this whole part it was accelerating, the speed was changing. So from 0 to 4.1 second, or we can say 4.1 second. Distance fallen while traveling at a terminal speed. So we need this distance. So it is making a rectangle. So half base into height starting from 4.1 and ending at 6. This is 1.9 and 20. So 1.9 multiplied by 20, which is equals to 3.2, 3. Oh, sorry, 38. So 38. And meter, because the speed is in meters per second. The height of the building. To work out the height of the building, you have to find the area of this whole figure. Because the height of the building is a total distance. Like if there's a tall building and a ball is dropped, a plastic ball is dropped. So the distance traveled by the plastic ball is equal to the height of the building. So we have to find the whole area under this graph. You can use a trapezium or you can divide the figure into parts, like a triangle and a rectangle. You can do that as well, or you can use a trapezium. In a trapezium, half sum of the parallel side into height. Like distance between the parallel sides. It will be half sum of the parallel sides. So this will be 6 plus, and this is starting at 4.1 and ending at 6. So 9. Half sum of the parallel side into height. The distance between them is 20. So this will be 1.9 plus 6, which is equals to 7.9, and divided by 2. So 7.9 divided by 2, 3.95 multiplied by 20, which is equals to 17. So the final answer, the distance, total distance traveled will be 79 meters. Like we need the area of this whole part. That's why. So, or you can divide into triangle and rectangle and then work out the area of each part. Then define acceleration. Acceleration is refers to rate of change in velocity. So how the velocity changes in a unit time, that's called an acceleration or increase in speed per second. Figure 1.1 shows a speed time graph for a train after 100 seconds. Train stop for 100 seconds. Then for time for 40 second to 100 second, calculate the distance travel. So from 40 to 100, what shape it is making? It is making a triangle. So we'll use a formula half base into height. So base is equals to 60 because from 40 to 100 and height is 25. So this will be 375, 750 meter will be the distance travel. This is equals to 750 meters. Then a train stop for 80 seconds. We have to complete a graph here. So, and the train stop for 80 seconds. So from 100 seconds, this train stop for 80 seconds. So it will stop till this point, from 100 to 180. Then accelerate to 30 meters per second with an acceleration of 0.6. So first we need a time for how long it accelerated. It accelerated for 30, like it reaches a speed of 30 seconds with an acceleration, but we don't know the time. So we use a formula to get the time. So acceleration is change in velocity divided by time. Acceleration of a train is 0.6. Final speed is 30. Initial speed is 0. And time we don't know. Cross multiply. So it will be 30 divided by 0.6, which is equals to 50 seconds. So means for 50 seconds, the train accelerates. So from 180 plus 50 means 230. So till 230 seconds, the train reaches speed of 30. So from 180 to 230 seconds, the train reaches a speed of 30. And then it travel at a constant speed. So it continue to move at a constant speed. So it travel at a constant speed. So this is a graph which we have to complete. First, for 80 seconds, it was at rest. So speed was 0. Then it was having a constant acceleration for 50 seconds. We work out by using a formula, and then it continued to move with a higher constant speed. Figure shows a motion of a train from one station to another. Calculate a distance between the two stations. So you can use a trapezium, or you can divide into triangle and rectangle. So if you use a trapezium, sum of the parallel side, half sum of the parallel side into height. So first parallel side, 10 boxes equals to 20. So each is representing 2. So 142, 4, 6, 8, 150. So this is 150. So the formula for trapezium, half sum of the parallel side into height. Or you can divide into two triangle and one rectangle. It will be half. One of the parallel side is 150. The other parallel side, it is starting from 10 and ending at 130. So from 10 to 130, so means it will be 120. So this will be 120. This parallel side is 120. So 150 plus 120 multiply by height. Height means the distance between the parallel side here. 10 boxes equals to 5. So each is 0.5. So this will be 15. And this will be 17.5. Because between 15 and 20, so 17.5. So half, like it will be half sum of the parallel side, 150 plus 120 times 17.5. This will give us 2,430 meter. That is a distance traveled by this train from one station to another. And the acceleration of a train for first 10 seconds, like this is a 10-second. It's a straight line. So this is a final speed 17.5. And the initial speed is 0. And so it will be final speed minus initial divided by time. So 17.5 minus 0 divided by 10, which is 1.75 meter per second square. That's the initial acceleration of the. Then the last question, figure 1.1 shows a rocket powered sled traveling along a straight track, and it is used to test the component before it is sent to the space. On a figure, mark a point P to indicate the time and acceleration is not constant. So if acceleration is not constant, any region like curved region, you cannot mark here. That will be wrong. You cannot mark even here. That is also wrong because a straight line. So it's on the curve you should draw where the acceleration is not constant. Then calculate the acceleration in 1 second. So how to calculate acceleration? Final minus initial divided by time. So this is 120 because 10 boxes equals to 400. So each is 40. So 120 minus 0 divided by time is equals to 1. So it will give us 120 meter per second square. That's the acceleration of this. The distance traveled from 1 second to 2 seconds. So I mean this region. There are two shapes. One is a triangle, another is rectangle, or you can use a trapezium. If you divide into triangle and rectangle, so this part is a rectangle and this one is triangle. So find area of rectangle. Length is 1 and the height is 120. And for triangle, half base into height. So base is 120 and height is starting from 20 and ending at 200 and this is 200, this is 220. So this is starting at 120, ending at 220. So this is 100. Because what we need the area of this part. So first area of the rectangle, 1 is the length, 1 and the height is 120. So this is total 120. Then but for a triangle, 3 boxes are there. So this was 120 and this is each box is representing 40. So this is 240. So it is 120 as well, like 3 boxes. So this is 120. So it will be half. Base is 1 and the height is 120. So when we simplify, this will be 60 and this is 120. So what is the total distance travel? 120 plus 60, which is equals to 180 meters. So 180 meter is the total distance traveled from 1 second to 2 seconds. So this was an exercise related to the distance time and speed time graphs. Any question or a doubt related to the session?